Hi everyone, this is Parvana Vaziri. In this slide, I'll be reviewing predictive models in SQL as part of George Mason University HAP 709. What is predictive analytics? Predictive analytics is the use of data, mathematical algorithms, and machine learnings to identify the likelihood of future events based on historical data. The main goal of predictive analytics is to use the knowledge of what has happened to provide the best evaluation of what will happen. In other words, predictive analytics can offer a complete view of what is going on and the information we need to succeed. How predictive analytics works in healthcare. In predictive analysis, different models are used to assign a score to data. The most common model is a predictive model. It can predict an outcome of a medical condition. The sample data with known attributes is used and the model is trained and enabled to analyze the new data and determine its outcome. Advantages of predictive analysis. Today, more and more healthcare organizations are using predictive analytics to support population health management, financial success, and better outcomes across the value-based care continuum. This information can be applied to predict the disease prognosis and outcome. Predictive analytics also enables clinicians, financial experts, and administrative staff to receive alerts about potential outcomes before they happen and make more informed choices about how to proceed with a decision in emergent and life-threatening situations. Here is an contingency table. We can see the true positive, false negative, and true negative. We're also going to talk about sensitivity and specificity. Sensitivity is ability to pick out individuals with disease, the true positive rate of the test. Specificity is ability to pick out individual without the disease, the true negative rate of the test. Positive predictive power is probability that an individual who receives an abnormal test score actually has the disease. And negative predictive power is probability that an individual who has a normal test actually does not have a disease. Likelihood ratios are used to assess two things. One, the potential utility of a particular diagnostic test. And two, how likely it is that a patient has a disease or a condition. Likelihood ratios are basically a ratio of a probability that the test result is correct to the probability that the test result is incorrect. The sensitivity and specificity of the test are the numbers used to generate likelihood ratios, which is calculated for both positive and negative test result and is expressed as positive and negative likelihood ratio. The calculations are based on the following formulas. Positive likelihood ratios are equal to sensitivity divided by 1 minus specificity, and negative likelihood ratios are calculated by 1 minus sensitivity divided by specificity. In its simplest expression, positive likelihood ratio is equivalent to probability that a person with a disease tested positive for the disease, which is true positive, divided by the probability that a person without the disease tested positive for the disease, which is false positive. Negative likelihood ratio, on the other hand, is the equivalent to the probability that a person with the disease tested negative for the disease, which is false negative, divided by the probability that a person without the disease tested negative for the disease, which is true negative. Probabilities and likelihoods. The likelihood is also known as the odds. When we say something has 1 in 9 odds, we mean that something happens one time for every 9 times it does not happen. Another way of saying this is that the probability is 10%. Probability is the measure of how likely an event is, and an event is one or more outcomes of an experiment. Probability formula is the ratio of number of favorable outcomes to the total number of possible outcomes. Notice that the likelihoods vary more dramatically than the probabilities. For example, 80% is just a bit more than 60%, but 4.0 is much larger than 1.5. Training and validating data. When working with a large amount of data, a set of samples can be set aside to evaluate the final model. The training dataset is the general term for the samples used to create the model, while the test or validation dataset is used to qualify performance, so that they provide an unbiased sense of model effectiveness. In training dataset, the samples of data are used to fit the model. In validation dataset, the samples of data are used to provide an unbiased evaluation of a model fit on the training dataset while tuning model hyperparameters. The evaluation becomes more biased as skill on the validation data set is incorporated into the model configuration. In the test dataset, the sample of data are used to provide an unbiased evaluation of a final model fit on the training dataset. Here is an example of an SQL query for probability. For this table, we want to calculate the probability occurring to each number's occurrence, and then want to get the number with highest probability. The SQL query for this table would be select number and occurrence. Then the query will be occurrence of 1 divided by select sum of occurrence from the table. Put it as probability from your table. Order by occurrence descending. Next, select the number from the table. Order by occurrence descending. Limit 1.